Question 8 tells us that X represents the number of times a customer goes to the grocery store in a 1 week period. It asks us to find the expected value of X, the average number of times a customer visits the store. Remember that the expectation or expected value of a discrete distribution is the same thing as asking for its mean. So really this is just asking us to calculate the mean of the distribution. Remember, to calculate the mean, we take each X value times its probability and add them all together. In this case, 0 times 0.3 is 0, 1 times 0.2 is 0.2, 2 times 0.3 is 0.6, and 3 times 0.2 is also 0.6. So when I add these together, 0 plus 0.2 is 0.2, plus 0.6 is 0.8, plus 0.6 is 1.4. So according to this table, on average, somebody goes to the grocery store about 1.4 times per week. Question 9 says, consider a binomial random variable with n equals 9 and p equals 0.7. Evaluate the probability that x equals exactly 3. When we have an exact number where it just says x equals, we just have to run the formula one time. The formula, remember, is n NCRx, p to the power of x, 1 minus p to the power of n minus x. In this case, our n is 9. Then we're going to use the NCR button. The given x is 3. Then the given probability is 0.7, which is going to be taken to the power of 3. Then 1 minus 0.7 is going to be taken to the power of 9 minus 3. Remember, on my calculator, I press the math button, I move over to PRB. On your calculator, you might have to find the PRB or NCR button, but you definitely should have identified that button before you begin the test. So when I start out, I'm going to do parentheses, 9, math, go over to PRB and choose 3, which is NCR. 3, end parentheses, new parentheses, 0.7 to the power of 3, end parentheses, new parentheses, new parentheses, 1 minus 0.7, end parentheses to the power of new parentheses, 9 minus 3, end parentheses, end parentheses. If I put that all in correctly, it gives me 0.021. For number 10, it's a little trickier. The reason it's trickier is because even though they give me the same general information, in number 9, it gave me an equal sign. In number 10, it gave me less than or equal to. I need to consider what's included in less than or equal to. So here, if it's out of 6 total things, the possible sample space is I get 0, 1, 2, 3, 4, 5, or 6 possible successes. Of these, the ones that are less than or equal to 1 are the first 2, 0 and 1. So really, this is another way of saying find the probability that x equals 0 and add that to the probability that x equals 1. So we're going to have to run the formula twice. The first time when we find p of x equals 0, it's going to be 6 NCR 0. Then it's going to be 0.2 to the power of 0. Then it's going to be 1 minus 0.2 to the power of 6 minus 0. The second time that we put it in for p of x equals 1, we're going to do the same thing, 6 NCR, except this time 1. It'll become 0.2 to the power of 1, 1 minus 0.2 to the power of 6 minus 1. We're now going to put these into our calculator separately, get the answers, and then add the answers together. So I'm putting in 6 NCR 0, parentheses, new parentheses, 0.2 to the power of 0, end parentheses, new parentheses, new parentheses, 1 minus 0.2, end parentheses to the power of parentheses, 6 minus 0, end parentheses, end parentheses. Put all that in, I got 0.262144. When I now do the same thing, except I do it for 1, anywhere where I saw a 0 previously, I'm putting a 1. So it's going to become 6 NCR 1, 0.2 to the power of 1, 1 minus 0.2 to the power of 6 minus 1. When I put that all in, I get a probability of 0.393216. I'm going to add these two together. When I do, I get an answer of 0.65536. I'd probably just put it in as 0.655. If they didn't give me any rounding instructions, I might put it in the whole way, but I think as long as they don't say specifically, they'll accept reasonable roundings. Again, the reason I had to run the formula twice is because of this less than or equal to sign. Question 11 says, let x be a binomial random variable with n equals 8, p equals 0.4. Find the mean. So the mean's very easy. They even give you the formula in the question. I just take n times p. If I do that, 8 times 0.4 gives me 3.2, which is the correct answer to this question. 12 is a little trickier. It had the same n and p, so I just didn't rewrite let x be a binomial random variable with n equals 8, p equals 0.4. But that carried down here to this formula for sigma. They say sigma equals npq. If that q is a little confusing to you, it's because I usually replace it with 1 minus p. Basically, p is the probability of success, q is the probability of failure. They're directly related. If I succeed 70% of the time, I fail 30% of the time. So I've introduced it more likely to you as np 1 minus p, but it's literally the same thing. If I do it for this problem, it should be the root of 8 times 0.4 times 1 minus 0.4. When I put that in my calculator, I put in the root sign. I make sure with parentheses that everything's happening under the root. 8 times 0.4 times 1 minus 0.4. And when I put that all under the root, the final answer is 1.3856. It asked me to round to 3 decimal places. 3 decimal places would be this 385, but since I'm dropping something that's 5 or larger, I have to round up. So when I drop that 6, I round this 5 up by 1, and my final answer becomes 1.386.